Hi Ambassadors! Before we dive into the lesson, let me ask you something. Imagine you're craving a milk tea. 1 cup costs 80 pesos. Fair enough, right? Now think about this. If you buy 2 cups, that's 160 pesos. And if you go for 3, it jumps to 240 pesos. The total cost depends on how many cups you buy. This is a real-life example of what we call function, wherein one value, the number of cups, affects the another value, which is the total cost. In today's lesson, we will explore how this kind of relationship works. We will learn how to understand, represent, and apply function in real-life situations, just like this one. Let's start with 2 important words, relation and function. A relation is any pairing of inputs and an output. It could be a one-to-one, many-to-one, one-to-many, and many-to-many relation. Function is a special type of relation where each input has only one output. This could be a one-to-one or a many-to-one function. Imagine this. You press button 1 on a vending machine. One time, a drink comes out. The next time, it gives you chips. Weird, right? That's a relation, because there is a connection, but it is not a function. Why? Because the same input gave you different outputs. Now imagine this one. Every time you press button 1 on the vending machine, it always gives you a drink. No surprises. That's not just a relation, but it is also a function. Why? Because the input, button 1, consistently gives you the same output. That's what functions are all about. Consistency. So functions are predictable. You press the button or the input and get only one output. Let's have a quick check. Let's imagine a real-life situation. You are selling an ice candy in your neighborhood. You sell each piece for 5 pesos. Now, let's say you want to track how much money you will make depending on how many you sell. This situation can be shown as a function, where the number of candies sold, the input, will affect your total earnings, or the output. We can represent this function in different ways. First, equation. An equation is like a math rule. Here, if you earn 5 per ice candy, the rule is f of x is equal to 5x, where x is the number of candies sold and f of x is the total earnings. So if you sell 3 pizzas, from the equation, f of x is equal to 5x. Since x represents the number of ice candy sold, then x is equal to 3. So let's simplify. 5 times 3 is 15. So when you sold 3 ice candy, you will earn 15 pesos. From the given equation, f of x is equal to 5x, we can now list down some values using table like this. If you sell 1 ice candy, you earn 5 pesos. When you sell 2, you earn 10 pesos. And when you sell 3, you earn 15 pesos. Did you see the pattern? Each time you sell an ice candy, you earn 5 pesos more. This helps us see the pattern of how your earnings increase. From the table, we can rewrite the values as points or ordered pairs. 1 and 5, 2 and 10, 3 and 15. Each pair shows the number of candies and the total earnings, where in math, number of candies sold represents the X values or the input, and the total earnings represents the Y values or the f of x or what we know as the output. For mapping diagram, this is like arrows connecting input to output. X as our input and f of x as our output. Each ordered pair will connect using arrow. Input 1 and output 5, 2 and 10, 3 and 15. It shows how each input has only one output, which what makes it a function. On a graph, we plot the points from a Cartesian plane. Since all the points are in the quadrant 1, let's focus on quadrant 1. On your coordinate plane, we need to start at the center, 0 and 0. That's the origin. Find first the x value, move left or right from the origin, then move up or down for the y value. For ordered pair 1 and 5, 1 is the x value and 5 is the y value. Since both of the x and y value are positive, this means from the origin, we need to move the point 1 unit right, and then 5 units up. For ordered pair 2 and 10, 2 is the x value and 10 is the y value. Since both of the x and y value are positive, this means from the origin, we need to move the point 2 units right and then 10 units up. For ordered pair 3 and 15, 3 is the x value and 15 is the y value. Still, since both of the x and y value are positive, this means from the origin, we need to move the point 3 units right and then 15 units up. This graph forms a straight line that goes upward because as you sell more, you earn more. These visuals help you see the trend easily. All these are different ways to show the same function. You can choose whichever helps you understand the situation best, whether you are looking at the table, graph, mapping, ordered pair, or just a simple equation. Let's have a quick check. Let's talk about another two important words, domain and range. Domain is a set of all inputs, the values of x, and the range is the set of all outputs or the value of f of x. For example, let's say each burger costs 25 pesos. That means we can represent the total cost with this equation. F of x is equal to 25x, where x is the number of burgers you buy. So if you buy 1 to 4 burgers, your domain or the possible number of burgers is 1, 2, 3, and 4. Now let's look at the total cost or the range. For 1 burger, that is equal to 25. For 2 burgers, 50 pesos. 3 burgers, 75 pesos. And 4 burgers, 100 pesos. That gives us a range of 25, 50, 75, and 100. Simple, right? One input, one clear output. That's a function. The domain refers to the number of burgers you choose to buy. And the range is the total amount you have to pay, depending on what you choose. Now, let's have a quick check. Let's talk about evaluating function. Sounds fancy, but it's actually simple. It just means you plug in a value for x and solve to find y. This process is called substitution. Think of a function like a machine. You put in a number, your x value. The machine follows the rule or the equation. And then the outcome is your y value or the f of x. Easy, right? Let's try an example. We have this function, f of x is equal to 3x plus 1. Now, let's say x is equal to 2. We substitute 2 into the function, so it becomes f of 2 is equal to 3 times 2 plus 1. Let's simplify the equation step by step. 3 times 2 is equal to 6, and then 6 plus 1 is equal to 7. So f of 2 is equal to 7. That means when the input is 2, the output is 7. Let's have a quick check. Now that you know how functions work, let's go deeper. Not all functions behave the same way. Some grow fast, some slow, some change direction. Let's explore 4 important types of function and how they connect to real life. Let's talk about linear functions. The general form is f of x is equal to mx plus b. Here, m is the rate and b is the starting value, or fixed amount you already have. Now imagine this. You have a part-time job at a coffee shop and earn 100 pesos per hour. That means your function is f of x is equal to 100x, where x is the number of hours you work. So if you work 1 hour, that means you have 100 pesos. If you work 2 hours, your total earnings will be 200 pesos. In 3 hours, you have 300 pesos. In graph, it is a straight line wherein your earnings go up steadily as your hours increase. That's a linear function. The key feature of this function is that there is a constant rate of change. Now let's move on to the second type, which is the quadratic function. The general form is f of x is equal to ax squared plus bx plus c. Think of it like this. Something starts low, increases, reaches its peak, and then goes back down. Like a story with a beginning, a climax, and an end. Imagine you throw a basketball into the air. What happens? It goes up, slows down at the top, then comes back down. That path, the height of the ball over time, is known as a quadratic function. The graph of a quadratic function forms a U-shaped curve. We call that curve parabola. If the graph opens upward, like a smile, it shows a minimum point. If it opens downward, it shows the maximum point. Maximum and minimum points are called the vertex. The key feature in a quadratic function is that the rate of change is not constant. It increases or decreases depending on the position relative to the vertex. The rate of change starts fast or slow, pauses at the minimum or maximum point, and then switches direction and changes speed again. Next up, exponential functions. The equation looks like this. F of x is equal to a times b raised to x. Think of it like this. These are the things that grow really fast. Like when something goes viral online. Let's say you post a video and the number of views doubles every day. For day 1, 100 views. For day 2, 200 views. For day 3, 400. And day 4, 800. That pattern follows a certain function. F of x is equal to 100 times 2 raised to x. The graph, it starts off slow, almost flat, but then it suddenly shoots upward, really steep. That is called exponential growth. So anytime you see something increasing super fast, like population, money in savings account with interest, or viral videos, you're looking at an exponential function. And the key feature of this function is that the rate of change becomes faster over time, either rapidly increasing or rapidly decreasing. Finally, let's talk about piecewise functions. These are the functions that have different rules depending on the situation. A great example, think of a jeepney fare system. Here's how it works. For the first 4 kilometers, you pay a flat rate of 12 pesos. After that, you pay 2 pesos for every additional kilometer. So the cost depends on how far you travel. That means the rule changes depending on the distance. And that's exactly what a piecewise function is. We can break it down like this. In a piecewise function, the set of x value is divided into intervals. And each interval follows its own rule or equation. Together, this rule forms an entire function. The graph broken into pieces, each with its own rule. The key feature of this is that different sections of the graph show different behaviors. Let's have a quick check. Let's apply this to solve a real problem. A food delivery service charges a base fee of 40 pesos, plus 8 for every kilometer traveled. What will be the cost if the delivery distance is 5 kilometers? Based on the problem, we can represent the situation using function. Let f of x be the total cost of the delivery. The 40 pesos is the base fee, plus 8 as the additional fee per kilometer, and x, which represents the number of kilometers traveled. So the function is f of x is equal to 40 plus 8x. Since we want to find the delivery cost for 5 kilometers, we substitute x is equal to 5 into the function. Let's substitute 5 in the given equation. And then, let us simplify. 8 times 5 is equal to 40. 40 plus 40 is equal to 80. So, if the food delivery travels 5 kilometers, the total cost will be 80 pesos. This function, f of x is equal to 40 plus 8x, help us predict the delivery cost for any distance. To summarize, a function links each input to one output. We can represent function through equation, table, ordered pair, mapping, and graph. We can evaluate function by plugging in values known as substitution. And we can use function to model real situations like money, travel, or social media growth. And that would be all about introduction to function. See you on the next lesson.